All right, everyone. So, in the last section, we talked about things like variables. Um, Variables store like a value, as we talked about. So if I were to make a variable like, called X, I could set it to number, like, 100. I could set it to a string or a collection of characters, like my name or San Francisco State University, something like that. I could even set it to a like a Boolean, which is basically a logical truth. It's either true or false. So like true or false. Okay. We also talked about the draw function. And the draw functions lets you basically loop over and over. And the reason why we might want to do this is so that we can edit or modify a variable during the program. So I'm just going to, make a new file real quick. So let's just say for the sake of argument, I'm going to make a variable, let x equal, I don't know, 50. Okay. Actually, here's what I'm going to do. Well, let's do a scenario. Let's just say for the sake of argument, I'm going to set x to 0. Okay. And since we know that the draw function constantly loops over and over and over, what I'm going to do is say, let's print out the value of x. Okay. Now, if I were to run it the way it is right now, it would just keep printing out 0, right? Because, currently x is 0. We haven't really changed that. And so, make a background, print 0 to the console, loop back. X is still 0. So when you tell it to print, it's still going to print 0, loop back. X is still 0. So you just kind of keep doing that over and over and over. But I could do something like this, right? Where maybe, let's do something like this, where maybe I'm going to take x. X is equal to x plus 1. Okay. So every time this draw function loop runs, it's going to keep changing or modifying the variable to add 1 to the current value. So in other words, it's going to start at 0. X starts at 0, and it prints out 0 here. Then we add 1, so now x is equal to 1. And then it prints out 1, and then it loops back, and we add, print it out again. Or actually, I run this, and now it should be 2, because we added 1. X is equal to 3, so on and so on, right? And if I were to run this, you can see it's running, right? Now, you can see it starts from 0, and it just kind of keeps going, right? It goes through 50, 100, blah, blah, blah. What if I wanted to do something where I only wanted it to print values from 0 to, say, less than 10? Unfortunately, there's no real way with what I've taught you so far that we could do that. I could literally like type them out, but the whole point here is that it has to be based on the variable, right? What I'm asking you to do is to evaluate something. Okay, what are we evaluating? What we're really evaluating is x less than 10? Okay, if x is less than 10, then you just keep adding 1 to it. When it gets to 10 or greater, it's no longer less than 10, and so therefore, we stop adding to it, right? And this brings up this idea in, in programming or any type of logic called an if statement. When you have an if statement, you evaluate something and you make decisions based on your evaluation. Okay. So we call these conditions, right? And a lot of things in real life are conditional. Okay. So for instance, most of you, I'm sure, have used Amazon or some sort of service to buy stuff online with, right? Now, a lot of these websites, you get free shipping if you spend more than a certain amount, meaning maybe you have to spend $50 or more. So if you spend, if you, at the end it evaluates, did you spend $50 or more? If you did, then you get the free shipping. If not, then you don't get the free shipping, right? A lot of online, streaming services like Hulu or Peacock or Netflix or whatever, they will give you a free 1 week or 1 month trial if you're a new customer. Meaning if you're already an existing customer, then you don't get the free trial. So it's conditioned, or it's conditional based on, are you a new customer or not? Okay. So these are things that we see in life, free shipping. It doesn't say the word if, but it basically, doesn't literally say the word if, but available to all customers over 25. Okay. But, enjoy 5% off your first order, meaning if it's not your first order, then you don't get 5% off, that sort of stuff. How do we write this in terms of syntax? Well, in JavaScript, the way we would write this is it looks like this. This is called an if statement. You write literally the word if, and then you have parentheses, and then you put what the condition is. And we'll talk about, what that might look like. Then you have curly brackets here that hold all the code. So this code block will run if and only if this is equal, or evaluates, as we would say, to true. If this is true, this runs. If this is evaluated to false or not true, then basically it bypasses this and it goes to there in the code. Okay. So let's kind of do an example of this. Okay. I'm going to go back. I'm going to go to my exercises. This is exercise 1. So here I have a variable I created. Okay. And it's called my number. I just, you can call it whatever you want. But right now it's set to 7. Okay. Actually, I'm going to set this to 15. Okay. What I want to do is I want to evaluate the variable my number. And if it's greater than 10, then I want to print out, number is greater than 10 using the print function. So what would that look like? Well, we talked about that you have an if statement like this. How would I say, how do we show, what I'm trying to evaluate is my number greater than 10? Well, the way we would write that is my number greater than, like in mathematics, 10. Okay. This is a question. Is the current value of my number greater than 10? It either is or it isn't. It's true or it's false. Okay. If it's true, what'll happen is it'll run whatever is in this code block, which currently is empty, but I can put literally whatever I want. Okay, so I'm going to say, print number is greater than 10. Okay. All right, so let's do a little Blackboard coding here. Line 1, I got a variable. I don't know if we want to go through the whole gimmick again of me keeping adding and subtracting things through this little bucket. But anyway, I have a variable called my number. All right, so we have our variable my number. It's equal to 15. So that's our setup. We run the setup, creates a canvas, puts a background color in there. So we get a little variable substitution. Is 15 greater than 10? The answer to that is true. That means all of this runs, and it should print number greater than 10. Let's test if this works. Hit play, and it works. Okay. Let's change this value. I'm going to change this value from 15 to 6, My number. All right, so my number equal to 6. Okay. Variable substitution, boom, is 6 less than, or sorry, is 6 more than 10? And the answer to that would be false. Okay. If something is false, then this does not run. And basically you sort of jump to here. Okay. Which means this should not happen when my value is anything below 6, or sorry, anything below 10. So let's try this out. I'm going to run it. And this part does not run. Okay. So basically anywhere, oh, let me do one quick thing. Let me do this. Let's set this to actually 10. Okay. Now this is a kind of a trick. It's a little bit of a trick because it seems like, well, is 10, is 10 greater than 10? And the answer is, it seems like it should be yes, but actually it's no. 10 is not greater than 10. 10 is equal to 10. Okay. So if I were to, you put this here, is 10 greater than 10? The answer to that is false. And then this doesn't run. Okay. Now, this was one, in this example here, we are checking one type of variable, right? We're checking a number. Is the number greater than? Is it less than? You can also check whether it's equal to something. What if my variable was, instead of my number, what if it was like my name? Okay. And I'm going to use a string. Remember, a string is a variable that's a collection of characters, like a name or a proper noun or something. Or it doesn't even have to be that. It could be like a sentence or something like that, right? So you can't, does my name equal greater than 10 or something? That doesn't really make logical sense. But what we could do is we could check, is a string equal to another string? So I could say something like this: is my name equal to David? Okay. And if it is, I will say something like names match. Okay. Now I did something a little different here. Let me talk about it. Notice that I have 2 exclamation points, right? Or sorry, equal signs, not exclamation points. Now, normally in math, we might say something like, 5 is equal to 5 or something like that, right? So why in programming do I need to use a double a double equal sign here? So remember that in programming, not in math, but in programming, when you use an equal sign, you're not saying something is equal to something. What you're doing is assigning a value. Okay, those are 2 different things. Like saying something is equal is like having a scale, right? Is this equal to this, right? But assigning just means you have this thing like a variable and you give it you're assigning or giving it a value like 5 or true or something like that. So if I were to do, oops, let me get out of this. If my thing was like this, what this is actually saying is not, is my name equal to the string of David? What this is saying is my name is now equal to the string of David. Okay. And since assigning something is never quote unquote wrong or false, it would always equal true, which is not what we're trying to do here. Okay. So if you're actually trying to say, is a number or is a string or is a Boolean equal to something, like the value of it, you want to use a double equal sign as opposed to a single. Okay. So, is my name equal to David? I'm going to hit play, and they do. Okay. And that works because is David equal to David? True. If I change this to some other name, like Joe or something or whatever, insert name here, is Joe equal to David? The answer to that would be false. It is not equal to. Okay. So then this jumps past that, and then that never runs. Okay. Another thing to note is that when you use strings are case sensitive. Okay, and what that means is that capital D is different than lowercase d. Okay. The reason why I don't want to get too deep into it is essentially every key or every letter or character is equal to a number. Because when computers actually match letters, computers don't read, they only understand numbers. They only understand 0 and 1 and things like that. What it actually does is all your letters actually go back to numbers. Okay. So really what's happening here is like, let's say I had lowercase a and uppercase a, right? And let's just say for the sake of argument, even though this is not actually what it is, let's say lowercase a was equal to 1 and uppercase a is equal to, say, 26. So is 1 equal to 26? The answer is no, it's not, right? And that's the reason why uppercase and lowercase don't work. Even though they're the same word, by capitalizing it, you're technically making the number different. And that's why two things will not match. So if I were to change, so because this is different casing here, David will not equal, David lowercase will not equal David uppercase. And then this part doesn't run. Okay. So this is actually how passwords work. When you go to say, if I were to like log into something like my email or something, right? And it's going to ask you to put in your password. What what your browser is actually doing is checking whatever you type into your input against a saved password. Okay. And, it's like, if I were to make this my password is equal to, whatever, David 123, David 1234, because that's my super safe password, right? Imagine this is like what when we have like an input, like, when you log into Canvas, which I'm already logged in, but let's pretend I hadn't, you're typing in that password, right? It asks you for a password, and then that's the password, and it's matching it against a password that it already has saved. And if the two match, then essentially, then you get to go to the next page, passwords match, go to next page. Okay. Oops, except I did not, I changed the name of the variable here. It should be my password, not my name. Okay. All right, so that's with strings. We can also do what we can also work with Booleans. Okay, now you remember that a Boolean is a true false. Something is either true or it's false. Okay, so let's just say for the argument, I want to know if someone can take the 327 class. Okay. And let's just say for the sake of argument, I don't know all the numbers, but let's just, whatever. Let's just say for the sake of argument, the 300 class is a prerequisite for the 327 class. Okay. So what I'm going to say is I'm going to make a variable called like passed or, completed 300. Okay. Or DES 300. So this is like, did they pass the 300 class or not? Because either they did or they didn't. Okay, it's a Boolean, right? In this case, pass just means getting a C or above. If anything above a C, you pass. Anything below a C, you did not pass or you fail. Okay. So what I want to test is, okay, if they have completed it, then they get to, go on to 427. So if completed 300 equals true, then, student is eligible to take, DES 327 or something along those lines, right? So once again, now when something is a Boolean, please note that you do not put them in quotation marks. By putting true in quotation marks, you don't make it a Boolean, you actually technically make it a string, okay? Like with strings, we basically are not checking, we are seeing, is this equal to the value of this? So what's going to happen here? This is going to substitute into here as true. Is true equal to true? I know that sounds kind of weird and meta, but that's essentially what we're asking. This then sort of evaluates to literally, is true equal to true? And the answer is true. I know that's kind of sounds a little weird, but that's the way it is. Because that's true, we can then, do this part. Okay. So if I were to come into here and hit play, student is now eligible to take 327. Let's say I have a student and they haven't done 300 for whatever reason. So theirs would be false. Okay. This is false. This substitutes as false. Is false equal to true? False. Okay. Once again, I know that's kind of weird and meta, but that's essentially how it is. True is equal to true. False is not equal to true. So if you're saying is false equal to true, that is false. Okay. I know it's weird. Just take a moment to think about it, and I think you'll see what I'm saying. So then this part gets bypassed, and then boom. Okay. Now, I did all that to do this. Remember how we had that whole, like, I'm trying to add numbers here, right? So we had X, and then it prints out X, and then we add 1 to X, right? Now, if I hit play, it just kind of keeps adding numbers here. And for the sake of argument, I just wanted to end at 10, okay? Or less than 10. So what I could do is I could say, well, if X is less than 10, that is when we add the number. Okay. So in other words, so we're starting at 0, right? I wish I could draw. I wish this drawing tool was a little better, but say Livy. All right, so this runs, we print 0. Is 0 less than 10? True, right? So then this runs X equals X plus 1. This is like my value of X. Sorry, I know this is really hard. I'm trying, I really am. I need like a little cool John Madden style thing I can just like write on. This is what's being presented in the console. Okay. So the value of X is now 1. This loops back. Print X. X is 1, so it prints 1 to the console. Let's do this again. Is 1 less than 10? The answer is true. So this, oops, sorry, I lost it. But anyway, now X is equal to 2. We loop back, it prints 2 the console. Is 2 less than 10? True. Is 3 less, it adds 1. Is 3 less than 10? True, blah, 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 blah. Then eventually it gets to 10. Is 10 less than 10? No, it's not. 10 is equal to 10. It's not less than 10. So then this never runs. And since, at least in this particular program, that's pretty much where it's going to end, because I have nothing in my program that's ever going to make X go back to anything less than 9. So it's never going to get either above 10 to base, it's never going to get above, it's never going to get back below 10 again. So it's never going to be able to get to this part again. Okay. So what's going to happen is it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it's going to it's going to keep repeating that forever. Okay. So if I hit play, okay, see how it just keeps adding 10 there. Now, how could we kind of use this to be kind of interesting? So you guys in your last lab did this thing with the draw where we like moved a circle across the page, right? So let me just do this real quick. Instead of printing X, what if I were to use X as the X value for, the circle function? Something like this, right? And for now, I'm just going to, X equals X plus 1. And so what should happen is the circle is going to move across the page. because it's constantly going like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, eventually you'll see it's actually going off of the page. And the reason for that is eventually X actually gets bigger than 400. I can prove that by literally doing this, letting us see the value. And you can see eventually it's going to get above 400. Right there, right? Now, let's just say for the sake of argument, I wanted the circle to stop in the middle, okay? How could I do that? Well, we could just do what I just did. Essentially, the middle horizontally is, 200, give or take. I mean, it is, but let's pretend we didn't know that. But half of 400 is 200. But anyway, if I were to say if X is less than 200, then I'm going to let it add 1. Otherwise, if it's 200 or more, then it will not add 1. So what this is essentially going to do is the circle will keep moving until it gets to the middle, and then it's going to stop. Okay. All right. There you go. All right. So we can see how we can kind of use this to do some really interesting, fun stuff. Okay. In the next video, we're going to expand on this a little bit. We're going to talk about an if-else statement, which basically says if the if statement doesn't run, then we can actually do something else instead. Okay.